If you listen to the news, it seems like AI, artificial intelligence, is pure magic. There's nothing it can't do. And some experts are even claiming it'll one day conquer the world. Well, that sure is a lot of hype. But is any of it believable? What is AI and how does it work anyway? In this video, I will explain how AI works as dead simple as I can. I may gloss over a few of the minor details to keep everything simple, but all the main points are going to be correct. So the big question, what is artificial intelligence? Well, artificial intelligence is just machine learning. Okay, what is machine learning? Machine learning is just linear algebra. That's all. There's your answer. Goodbye. I'm just kidding. I can go a little bit deeper than that. Let me start with a non-computer version to get some of the basic ideas down, and then we'll move on to the computer world. Imagine building a simple coin sorting machine. You'd have a slot at the top, a bunch of levers in the inside, and a slot at the bottom where your coins come out, already sorted. A random coin goes in the top, it falls down and hits that first lever. Now that lever has a spring on it, so if the coin is heavy enough to tilt the lever, the coin will fall down into the slot below. And if it's not heavy enough to tip the lever, the coin will just roll down onto the next lever. And the cycle repeats. Pretty simple design, and if all the tensions on all those springs and levers are set just right, the machine will sort the coins perfectly. To tune up that machine, you'd run a coin through and adjust each little knob on the levers until the coins go where you want them to go. Now imagine automating the process a little bit. Let's add some tiny little motors to those springs. And when you turn the motor on, it tightens that spring just a little bit. To turn the motors on, let's add a little button at the bottom. We'll run a coin through, and if it sorts correctly, we're done. If it doesn't sort correctly, we push the button, and the little motors tighten all those springs just a little bit. Not enough where the machine works perfectly now, but we're one step closer. So we run another coin through and repeat the process. Eventually, after hundreds of coins, the machine is tuned perfectly. This process is very similar to machine learning. Learning might be a strong word. The machine isn't really doing any thinking. I think tuning is probably a better word, like tuning a piano, but they call it machine learning. Running those samples through is called training. But again, it's just a bunch of springs and levers, so it's not training like a person would train, but the machine does get better at what it does. So let's take this same concept into the digital world. A classic example is training a computer to read handwritten numbers. We show the computer a picture of a handwritten number. Now, a digital picture is really just an assembly of pixels, little tiny dots that, when put together, form an image. To keep things simple, let's start with a small image. So 10 by 10 pixels. So that'll give us 100 total pixels. A pixel can be black or white. So we'll assign it a value of 1 if it's black or 0 if it's white. This gives us a list of 100 ones or zeros. We're going to make a second list. It can be a list of 100 items, it can be bigger, or it can be smaller. For each spot on the list, we're going to add up all the numbers of that first list. But each number is going to be multiplied by a weight, depending on how important that number is. Let's say in our picture, the corners aren't as important as right in the middle of that picture. So for the corner spot, we can multiply that by 0 or some very small number, and that means it's not important. And for those pixels in the middle, we multiply it by 1, which means it's very important. And for the ones in between, we multiply by 0.5, means it's kind of important. Since we're adding up so many numbers, 100 of them, these numbers are going to start to get really big. So we don't want to run out of computer memory. So we'll do some simple math, like take an average. And that'll make the number a little smaller and more manageable, but doesn't really change the information it contains. Then we move on to spot 2 on list 2, and we do it again. We add up all the numbers in the first list, multiply by a weight, and these weights are completely different than the ones we used in the first spot. And we just fill in the list. We do it again with a third list using numbers from list number 2, and we can keep going on and on for as big as we want. Each spot on a list is called a neuron, and the whole system is called a neural network, because a diagram kind of looks like neurons in a brain. But it's just a graphical representation. These connections aren't real. It's just information in a computer system. There are no physical connections, no wires, anything like that. We're just adding up numbers here. And now it's ready to train the system. We take a picture and feed it into the input. The algorithm does its math and it spits out a number. We know what the number is supposed to be, so the algorithm takes the difference of what it came up with what it was supposed to come up with, and uses that to adjust all those little weights. And those weights are like the knobs of our coin sorting machine. And that's all there is to it. By training with hundreds and thousands of pictures, this algorithm can end up 95 or more % accurate. And that's all there is to it. There's no thinking going on. There's no real intelligence there.
B-A bay, B-E-B, B-I bicky by, B-O bo.
It's just a sorting machine, taking averages and sorting them. And there's just a lot of them. And it does this a lot of times. Each layer has 100 items in it, and there can be dozens or hundreds of layers if we want. So it's complex, but there's no intelligence there. The only intelligence is from the person who built this neural network and the person who's training. It can be spookily impressive at times, but any intelligence we see is just an illusion. I know what you're thinking. Oh yeah? Well, how does it know what I'm going to write? When I make a typo, how does it know what I wanted to say? And you've seen them write paragraphs all on their own. How does that work? Well, as surprising as it seems, yeah, it's all the same. It's still just another neural network. It's a little bit better designed. They add in loops. That way it can use something it's already figured out to help it figure out what comes next. But again, it's just math and lots of training. By going through millions and millions of text messages, it can estimate what the next word should be based off of what was already written. For me, I'm not that impressed. Those autocorrects and autocompletes don't work that well for me. And now you want to ask, well, what about AI creating pictures out of thin air? That's not just adjusting weights and taking averages, is it? Well, yes, it is. If you can imagine our first example of reading a handwritten image, it's just a big sorting of numbers and weights and averages. Well, what if we ran the numbers backwards? We put the number 8, let's say, in the output and fill in all those numbers and all those layers all the way into the beginning, which was our ones and zeros, which represented black pixels or white pixels. And you fill that in and you can generate an image. Well, the concept is good. In practice, that doesn't work that well. So what they'll do is take two neural networks. One of them is designed to recognize pictures of cats, let's say. And the other one is designed to draw pictures. And you let them talk to each other and share information. So one neural network will draw a picture, just a bunch of random dots on a page. And the other neural network will look at that and say, nope, not a cat. So it tells the first one it was wrong. The first one does all its adjusting and draws a slightly better picture, but still just dots on a page. And they cycle through again and again until one of them can generate a picture that fools the other one. And it comes out pretty good, although we've all seen some hilarious mistakes these AI can make. Neither of these neural networks knows what a cat is. They're just sorting data. There's no real understanding or recognition or intelligence to these AIs. All the intelligence still lies with the programmers and the people training these AIs. But if that's true, then how come some people are saying AI is going to take over the planet? That true intelligence is right around the corner. Artificial General Intelligence, or AGI. Well, some philosophers and scientists say that our own brains aren't much different. We're just a bunch of neurons connected. And that's it. We're just very large information sorters. And the reason it seems like there's more going on and some true understanding is because our brains are so much bigger with billions and billions of connections instead of the millions and millions of some of these modern AIs. So some people believe that if the computer intelligence gets complicated enough and big enough, real intelligence will just emerge out of those weights and averages that it's doing. Of course, other people say that's a big steaming pile of bull plop. So, what do you think? Thanks for watching. Please consider subscribing to my channel and like and comment if you enjoyed this video.